Okay, let's take a look at a couple of examples for our Chapter 6 homework. This is problem 6.3 in your book if you want to follow along. 6.3 says that Delta Airlines quotes a flight time of 2 hours 5 minutes for its flight from Cincinnati to Tampa. Suppose we believe that the actual flight times are uniformly distributed between 2 hours and 2 hours and 20 minutes. So part A asks us to show the graph. Now, to be honest with you, Excel does not make this easy. So you don't bother to draw the graph unless the problem specifically asks you to do it. But this is a uniform distribution, and what that means is that the flight is equally likely to land at any time between 2 hours and 2 hours and 20 minutes, or between 120 minutes and 140 minutes. Within that time, any given time, the probability is 0.05. And how did I get that probability? That's the first thing I need to do. I need to calculate this uniform probability. And the formula for that is the function, or the probability, equals 1 divided by b minus a. And you can think of b minus a. B is the maximum time and a is the minimum time. Okay, so the maximum time I put here is 140 minutes, and the minimum time is 120 minutes. So the probability function for this uniform distribution is 1 minus 140 minus 120, which I put here, 1 divided by 140 minus 120. Okay, and that is the probability. So the probability at any time is 0.05 or 5%. So given that, and given that this is a continuous probability distribution, which means it's equally likely to arrive at any time between these two times. So it might come in at 121 minutes, it might come in at 120 minutes and 10 seconds, it might come in at 127 minutes and 15 seconds. So it can arrive at any time in between 120 minutes and 140 minutes, and it's equally likely to arrive at any of those times. So given that, the probability of it arriving at any exact time, the probability of it arriving at exactly 130 minutes, the probability is 0 in a continuous probability distribution. And I'll show you why in a minute. So let's look at the problem. So B says, what's the probability that the flight will be no more than 5 minutes late? Okay, so if it's 5 minutes late, that means it would arrive in 125 minutes. So what I need to do is I need to find the area, this area here, now, this area right here. So this rectangle, everything within that rectangle is the probability that will arrive no later than 5 minutes later, no later than 125 minutes. So all I need to do is I need to calculate the area of this rectangle. And the difference between 120 and 125 is 5. So the width of the rectangle is 5, and the height of the rectangle, this is definitely not in proportion, the height of the rectangle is 0.05. So for B, it would just equal 5 times 0.05. So the probability of arriving no more than 5 minutes late is 0.25 or 25%. Okay? C wants to know what's the probability that the flight will be more than 10 minutes late? So if it's more than 10 minutes late, so 10 minutes will be 130, okay? And more than 10 minutes late would be the difference between 130 and 140, so it would equal width of 10 times the probability function. there's a 50% chance that it'll arrive more than 10 minutes late. Okay? And then D says, what's the expected flight time? So if all of these times are equally likely, the expected flight time will just be an average of those times. So I could just put in equals average of all these times. And so the expected arrival time, the expected flight time would be an average of all those equally likely times, or 130 minutes. Okay, so that's a uniform probability distribution, pretty easy to understand, pretty easy to figure out. In reality, in the real world, uniform probability distributions are kind of rare, that it would never come in early and it would never come in more than 20 minutes late, which is basically what you're saying here. But as an exercise, it helps understand how these probabilities are computed. Now let's look at problem 6.17. So 6.17, again, I've got a normal curve here, a normal distribution, normal probability distribution. And this vertical line in the middle is the mean. So let's look at the problem. It's problem 17. Let me find it real quick. Problem 17 is another airline problem. It says domestic airfares in the United States rose to an all-time high of $3.85 per ticket. So that's the mean. The mean cost of domestic fares is $3.85. So I put that up here. I just put mean $385. And the standard deviation, this is all airfares in the United States, the standard deviation is $110. So one standard deviation is $110 from the mean. So $110 less, $110 more, that'd be one standard deviation. Okay? Then it wants to know for A here, it says, what is the probability that a domestic airfare is $550 or more? All right, so this is $385. This is less than $385. This is more than $385. So let's just say that $550 is around here someplace. Okay, and we want to find the probability of, we want to find the area of this area here, but it's not a rectangle, so it's a little harder to figure out. In fact, if we were to try to figure out this area mathematically, we would need to use calculus, and we don't want to do that. Okay, but luckily Excel will do it for us. So we're trying to find out the area of this little part here, and that will tell us the probability that a ticket will cost $550 or more. All right? Now, unfortunately, or fortunately, the way that the function in Excel works is it will tell you everything from the left of a certain area. So it will tell you everything that is less than $550, okay, the probability of everything less than $550. But the probability of some airfare is 1, right? So if we say that this equals 1, or 100%, minus all of this, then that will be the probability of having an airfare of 550 or greater, okay? And that's what we're trying to figure out. Luckily, again, Excel makes this very easy for us. It gives us a function called normdist, or normal distribution. It's just equals N-O-R-M, normdist, not normsdist, but just normdist. And then it tells you what it wants right down here. It says, okay, what's X? Well, X is 550, okay? And then it wants a comma, so you put in a comma. And then you put in the mean is 385. And then you put in another comma. Then it wants the standard deviation, and there's the standard deviation. And then you put in another comma. And it wants to know if it's cumulative or not. So we want the cumulative distribution. So we just put in the word true. Okay? That's all we need to do. And then we press enter. And it tells us that basically what it's saying, it's giving us this amount. It's saying that there's a 93% chance that the airfare will be less than $550. So for the airfare to be more than $550, it would be 1 minus 93%. So I can do that just by putting in here in front of the norm diffs. I just put 1 minus, and that's my answer. There's a 0.067 probability, or about a 7% probability, that the airfare will be $550 or more. Okay? So B wants to know what's the probability of the airfare being $250 or less. So again, I just use equals norm dist, and then here's x, then comma, here's the mean, then comma, here's the standard deviation, then comma, then true. Okay? Now, because I wanted $250 or less, so here's $250 or less, so this is the area that I wanted, and that's what it gave me. So there's about an 11% chance that a ticket will cost $250 or less. C wants to know what's the probability that the airfare will be more than $300 but less than $500. So I need to figure out the probability for each of these and then subtract one from the other. Okay? So again, I just use norm dist, $300, the mean, the standard deviation, and true. And then I do the same thing for $500, equals norm dist, $500, the mean, the standard deviation, and then true. Okay? Now, what's the difference? So it would just be the probability of being less than $500 minus the probability of being less than $220 will be what's in between. Okay, so it's just equals this minus this, and that's the answer. So I'll just make these all yellow so we can see what the answers are. Whoops. So this is the answer to A. This is the answer to B. This is the answer to C. Okay. Then D wants to know, what's the cost for the 3% highest domestic airfares. So it wants to know over here, the top 3%. So what's this dollar amount? So basically, I want to know what 97% is, okay? So 3% is here. I want to know what this other 97% is. So what I'm going to do is I'm going to use another function. It's called the inverse of the norm dist. So it's called norm, oops, got to spell, norm dot inverse. And you just do what it says. So first I find the probability. The probability is 0.97. Okay, there's a 97% probability. Okay, then I want comma, then I want the mean, then I want the standard deviation. Okay, and so what that means is that $690 or $591.89 covers